All right, in the last video, we talked about exponential functions and their graphs. Today, we're going to talk about their inverses or logarithms and their graphs. So what I want you to do is kind of what we did in the last lesson when we said, you know what if we have 2 to the x? Let's graph it. And so that's what we're going to do starting off is graph 2 to the x on this graph here. And this time I'm going to have you go from -4 to 4. Make sure you plot those values. So pause the video and as a review, graph 2 to the x. All right, I've taken you've given that 2 to the x a try. Take a look and see if it matches this graph right here. That's about as best as I could do it by hand, but the chart should match up perfectly. And remember what I do with that is I go through and say 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16. And then once I know 0 through 4 like that, I can take the reciprocals to figure out 2 to the -4th might throw me for a loop if you ask me, when I'm walking down the street, you say, Mr. Burnett, what's 2 to the -4? I might have to think about it for a moment. But if you've already got this written out, it's pretty simple. I know it's just going to be 1 over 16. And then 2 to the -3 is 1 over 8. And then 1 over 4. It's like it's working backwards. And we're talking about the reciprocals of these numbers right here. Now, I can't really accurately plot 1 over 1/16 or 1 over 16 and 1 over 8 on this graph. But it should be looking like it's getting closer and closer as we go towards -infinity to 0. And then it grows all the way up to 1. And then once it hits 1 and goes into the positive exponent values, it shoots up, right? Now, these points should be pretty accurate because you can do 0, 1, 1, 2, 2, 4, 3, 8, and 4, 16. Those shouldn't be a problem. Now, what does it say to do now? It says for the table above, switch the x and the y values and then plot those points. So that's what I want you to do now. Take these, switch them, and plot the points on the graph up here. So pause the video and try that. All right, I've taken that you've given that a try. You've switched the x and y column and then you plotted the points. Let's see how you did. So if we look over at this right here, I've switched these values from up here, switched them, and this is what I got. When I put 1/16 in for x, out spits out a -4. And so forth as we go through the exact same ones we did up above, just switched around. More importantly, when I graph it, what does it look like? It looks like this right here. Graphed in green is what we did in the bottom, and pink was 2 to the x. This function right here is what we call log base 2 of x. And then the one up top, of course, was 2 to the x. Now, what do you notice about these two? Well, I put this dashed line in on purpose. That shows that if we fold these over y equals x, they match up perfectly. And what did we say, graphically speaking, when two things are reflected over the line y equals x, they match up? Then we say they are inverses to one another. So the log base 2 of x and 2 to the x are inverses to one another. They undo one another. And it actually meets all the requirements that we have for functions to be inverses. Notice that the pink function here does pass the horizontal line test. I don't have to restrict the domain at all to come up with the inverse. And then we can also investigate the f of g of x if we want to. We can algebraically show that these two are inverses. For instance, if I take the f of g of something here, what do I get? Let's pick a number like, I don't know, let's do 8 right here. So when I take the g of 8, what comes out of that? Well, the g of 8 leads me to 3. And then I'm going to take the f of 3, and notice the f of 3 gives me 8. And that works with any of these numbers that I pick over here because I switch the x and the y column in the chart. So anytime I take the composition of the two functions, I'm going to get the original input. Notice 8 goes in to the composition of the two, 8 comes out. So that's another way, that's giving you a specific example, not really proving all in all that they're like for any x value that they're inverses, but it works for our investigative properties right now while I'm trying to show you they're inverses to one another. So graphically speaking, it asks us to find two reasons here that they're inverses. Graphically speaking, they're reflected over y equals x, and then we can talk about the table. It's the x and y columns have been switched, so we can say they're inverses that way. And then we can also show that the composition of the functions are giving me the original input there. So that is just kind of a way of showing you that logarithms are inverses to exponential functions. Now, this particular one was talking about a base of 2. So same thing happens when we talk about a base of 3. So if I gave you 3 to the x, the inverse to that is log base 3 of x. If I gave you 10 to the x as your function, the inverse to that is log base 10 of x. Now there are some special things that we go about when we talk about 10 to the x and e to the x. So let me show you that. If I say I've got 10 to the x right here as my function, then the inverse to that is the log base 10 of x. These two are inverses to one another. But typically, log base 10 shows up so much that we don't write the 10 here. So we just say log of x. So when you see something is saying log of x, it's not written, but there's actually a base 10 right there. So if the number is missing down here for the base, we know we're talking about base 10. Another one that's kind of funny like that is when we have e to the x. So when I say y equals e to the x, remember we talked about that in the last video, graphing e to the x, then sometimes, the inverse to that, we write it out as this right here. Now this looks weird. The natural log of x is how we read that. That's the same thing as saying log base e of x. Now why do mathematicians write out ln of x instead of e to the, or log base e to the x? I don't know. Maybe this looks too much like log e, which sounds weird. But you're going to see it like this every time. We never write it out as log base e of x. I do sometimes in this class just to kind of get students going when they're solving these equations. They might need to think of it like that. But I want you to get in the habit of writing out as natural log of x. You can even see it on your calculator. They should show up as natural log of x. If you see e to the x right here, there is ln standing for natural log of x. And notice we have 10 to the x right there. And then this is just log, meaning log base 10, the inverse to 10 to the x there. So keep that in mind as we go through these. We're going to see it a bunch. But that's just the basic introduction to graphs of logarithms. You can think of them as the inverse, because they are, the inverse to exponential functions. Now what we're going to do is actually go through, like we did with exponential functions, we're going to look at this sheet right here, and we've got 5 to graph in Desmos. Remember, we're going to use kind of like Desmos to check it here if we need to, but let's see how much we can do by hand. You've got 5 questions. Go through as much as you can. Use Desmos if you need to. So pause the video and give that a try. All right, so I want to take you through a couple of them. Maybe you've gotten stuck. So let's take a look at the first one. Hopefully you didn't get stuck with the first one because we just did that one. But just in case you did, that's what I got for our answers there. Now we did that using a larger graph, remember on this one, but it's the same values. We just threw out -4 and 4, and everything else is graphed there. Now, if it helps you, you should have already seen the exponential functions graphing video, and we did a worksheet like this, didn't we? So that's what we did in the last lesson, and this was 3 to the x, and these are the values we got for 3 to the x. So the log base 3 of x should just be these two switched around. And that's what I'm going to do. I've got 1 over 27. Out should spit the opposite there, -3. And you can go on down the list like this right here. And so notice, because they're inverses, the tables are just flipped around. There you go. It's my tripod that's holding up the camera is messing that up. So here was 3 to the x from the last video. And here is the log base 3 of x. That tripod in my way. Let me fold this so you can see it better. So this is 3 to the x right here. So notice those two charts, they are just flipped around. And then it makes it a little bit easier to graph it. I can say, okay, I've got 1, 0 as a point, 3, 1. Oops, 1, 0 is right there. 3, 1 is right here. and then 9 comma 2. And then the rest is going to be off the graph. So it's going to come like so. Pretend like I didn't write that dot right there. And so that's the log base 3 of x graphed out. We can compare it to the other function we did. This is 3 to the x. That's log base 3 of x. And notice they are inverses to one another. All right, same thing with the one below. We have this from before we said, this is 5 to the x, and I want to graph log base 5 of x over here. So it's going to be these switched around. So once again, we got -3, -2, -1, 0, 1, 2, 3. And those are the points I'm going to graph, 1, 0, and then 2, 25. Nope, sorry, not 2, 25. I'm reading that backwards. 5, 1. 5, 1. And then 25, 2, which is going to be way out here. So this is what my graph is going to look like right here. Notice you can compare it if you want to our original 5 to the x, and they should look like they are being reflected over the line y equals x. We're going to see in Desmos here how all of these compare, but we're working through, like we did with the exponential graphs, doing logarithmic graphs. So the next one, number 4, is talking about log of x. Now remember, the log of x is the same thing as saying log base 10 of x, and we can compare it to our graph from exponential functions. Because they are inverses, then let's see, this is 10 to the x, and this is log of x, log of x, and that's like saying, remember, log base 10 of x. So they should be inverses to one another, because they are. And we're going to flip around the x and y values here on the chart. So this goes -3, -2, -1, 0, 1, 2, 3. And when we go to plot these, we've got 1, 0, and then 10, 1. And this one's not going to let me show much on the graph. Whoops. This is why I don't want to do it on a marker. But it's very, very much like this one where it didn't let me show much here. We went to 0, 1, and then way up here, that's the 10 to the x graph right there in red. So that's what's going on with these. Now in this one, I actually put the decimal form of all of this right here written in black. But it's still, when you switch around the x and y axis, x and y columns here, remember this was e to the x. This is going to be the natural log of x. Remember, that's the same thing as saying log base e of x. But we don't write it like that. We write it like natural log of x because we're math people, and that's what we do. So we're going to switch these around. We get -3, -2, -1, 0, 1, 2, 3. And once again, when we go to plot these, we're at 1, 0 again. Boom, that's okay. And then 2.7 something, 1, so about right there. And then at 7.3, we're at 2. And then at 20, way out here, we're at just 3. So it doesn't rise very fast, does it? And there's our graph. Once again, it should look like the inverse to our e to the x. Now I want you to take a moment and graph these in Desmos. So let's switch over to Desmos. This is from the last video when we went through and we graphed exponential functions. This time I want to go through, let's take it back to a normal zoom here, and I want to try to graph the inverses to these. So we're going to start with log base 2. Let's see how we can do that in Desmos. So we got y equals log, and if I just arrow over to the right, nope, I thought it was to the right. Let's see. Let's show the keyboard here, go to functions, and we should have logarithms under miscellaneous. Whoops, let me pause it. Well, I thought there was an arrow over key, and maybe there is, and I just forgot about it. But if you go to functions, miscellaneous, right here is log base A, and that gives me the option to put in the correct base there. So this is going to be log base 2 of x, and that's what I get here. Now, instead of going through all that again, I'm just going to highlight that, Control C for copy, and down below I'm going to paste and change my base here to 3. And there's log base 3. Let's do that again. So I've still got it copied, so Control V, and change that to a 5. Whoops, not right there. Let's see if we can go back and make sure we get it subscripted here. Change that to a 5. There's log base 5 drawn in black. And then let's do it with a 10. Now you don't have to put 10 in there. It should show up if you just say log of just log of x. That's the same thing as log base 10. And then lastly, we had what? The natural log of x. So you should be able to type in just ln, and it knows you're talking about the natural log of x. And there it is in blue. So first we're going to look at all 5 of these graphed together. And notice what we've got here. It's kind of like when we graphed all the exponential functions together in the last video. They all cross right here at 1, 0. So that's something important to note. When you're graphing logarithmic functions, I expect it to go through that point unless you've got a transformation going on. And so keep that in mind. Remember, if we look at the inverses, let's go ahead and graph those again. Here are the inverses to those logarithms. Notice they all go through that special point 0, 1. The logarithms go through this special point 1, 0 because they are inverses to one another. So it should look like everything is being reflected over what? Y equals x, right? So there's y equals x graphed, and you can see that they match up with that thought. All right, so there's the inverses. Once again, remember on exponential functions, we said as the base gets larger, it gets closer and closer to the y-axis. So not even knowing what these equations are, I know that this, here, let's zoom in, this purple graph right here that the cursor's over, it must have a larger base than the red graph right here that's spread out way over here. Same thing going on with the inverse. This green graph probably doesn't have a base as large as the red one. And if we look, the green graph has a base of 2, and the red one has a base of 10. So 10 has been in further towards the x-axis. So that's our graph there. Hopefully, taking a look and comparing these graphs kind of helps you feel a little bit better about what a logarithm is, and that it's an inverse to the exponential functions. Now we are going to start going through some algebraic properties of logarithms that will also deepen your knowledge of them and how they are inverses to exponentials. But I thought, graphically speaking, looking at them that way was probably the best way to introduce you to them. But like I said, we will have some more problems coming up where we're looking at the algebraic approach to it. Okay? Let me know if you have any questions about graphing logarithms, and thanks for watching.